numbers. So in today's session, what we are going to go over is the quadratic equations, maxima and minima. So in the previous lesson, what we have gone over is understanding how a quadratic equation works, I believe. So a general quadratic equation as a function could be represented by ax squared plus bx plus c. So what we have to do is, in the previous class, we noted that if we want to find the x-intercept, which is, so let's say if we have a quadratic function that follows this shape, which we call a parabolic shape, has two x-intercepts, one here, one here. If I say this as my a comma 0 and this as my b comma 0, we can find these a and b using a simple substitution of fx equal to 0. So we get ax squared plus bx plus c equal to 0. And following this, if we use our quadratic equation to find x, which is minus b plus or minus square root of b squared minus 4ac over 2a, we would get two answers for x, and those are the values of a and b. And we call these roots or solutions for the quadratic expression. So in today's lesson, what we are going to look at is how to find the maximum point. So which is this one. So in this case, this is a minimum point. If your graph looks like this, then this is referred to as your maximum point. So what we have to do in order to find the minimum and the maximum is we have to make it a perfect square. So how to make it a perfect square? So let's take a simple example, which is fx equals to x squared plus 4x plus 4. So we have to make it a perfect square. So we know that if we expand x plus 2 whole thing squared, we would get x squared plus 2 times 2x plus 4, which is x squared plus 4x plus 4, which is the function that we have. So we can say that this is x plus 2 whole thing squared. Sorry, x plus 2 whole thing squared. So in addition to the perfect square that we have, we will call it 0 because we do not have to add any number in addition to this, because this itself is x squared plus 4x plus 4, which is the function. So we do not have to add any number here. So these two numbers are what we are interested in. So this one and this one right here. So if we can find a function in a common form that looks like a x minus h whole thing squared plus k, then we would say the maximum or the minimum point is achieved at the coordinate h commas k, and we call this a vertex, right? So a vertex could be either a maximum or a minimum, and that coordinate of the maximum and the minimum is what we call h comma k. So that is why we want to make it a perfect square. So I will show you in the next example how to make it a perfect square, but this is just a very simple example of how to, or what is a perfect square and how to find the maximum and the minimum. All right, please take this down and let me know. Right. So let's take another example of fx equals to x squared plus 13x plus 4. So this is a very random example. So the method to make it a perfect square is quite simple. So we will write the x squared as it is. And this 13, we will write it as a multiple of 2. So 13 as a multiple of 2 is pretty simple. What we had to do is we had to divide 13 by 2 and we had to multiply it by 2. So virtually, it is like these two will cancel each other out, but we need those two in place. And we have the x, right? We have the x right here. Then we have to scale this number and we have to add it once and subtract it once, right? And we have the remaining, which is the 4, and we will have to add those numbers. So the first three terms that we have here is what we can write it as x plus whatever this number is, which is 13 by 2 whole thing squared. So all these three terms can be written as this. And we have 4 minus 13 by 2 whole thing squared. So 13 by 2 whole thing squared is 169 by 4. So that is x plus 13 by 2 whole thing squared, 16 minus 169 by 4. And that is x plus 13 by 2 whole thing squared. And you can either use your calculator or you can do your mental math. So 153 by 4. So what is the vertex? So the vertex is the negative of this number, which is negative 13 by 2, comma, whatever this whole number is, which is negative 153 by 4. So that is going to be your vertex, right? Please take this down. If you have any questions, please let me know. And we will do a few more examples.